Moving on to the next part of our discussion on impulse and momentum, we have collisions. A collision happens when you have two or more moving objects and they move into each other or they hit each other. We can classify collisions into three types. You have elastic collision, wherein if you look at the kinetic energy is conserved. For this type of collision, you can use conservation of energy without any problems. And then you have inelastic collision, wherein there is kinetic energy loss. You can still use your conservation of energy equations or analysis, but unless you are able to take into account the loss in kinetic energy, you will have difficulty in analyzing the collision. For example, you will have difficulty in getting the final kinetic energy if you are able to determine the loss in kinetic energy. And then you have perfectly inelastic collision where there is kinetic energy loss, and the objects stick together after the collision. So this is just like inelastic collision, but the objects will stick together after the collision. Regardless of the type of collision, momentum is conserved. Initial momentum is equal to final momentum. So it stands to reason that when there is collision or when the problem describes objects colliding, it we can use conservation of momentum to analyze the problem. And now for a couple of examples. First, consider the following problem. You have two identical billiard balls, A and B, which are moving as shown in the figure. A is moving at 3 meters per second at an angle of 45 degrees with respect to the horizontal, and B is moving horizontally with a speed of 5 meters per second. The balls collide. After the collision, ball B travels back the way it came at a speed of 2 meters per second. What is the speed of the ball A, after the collision? The two billiard balls are identical. They have the same mass. So MA is equal to MB. Let that be equal to simply M. Let angle theta be 45 degrees. Before the collision, the speed of A is 3 meters per second. So VA initial is equal to 3 meters per second. As for the initial speed of B, VB initial is equal to 5 meters per second. After the collision, the problem tells us that the final speed of B is 2 meters per second. VB is equal to 2 meters per second. Using conservation of momentum, we have initial momentum is equal to final momentum. PA initial plus PB initial is equal to PA plus PB. Expanding our equation of momentum to mass times velocity, we get mva initial plus mvb initial is equal to mva plus mvb. We can cancel out mass, giving us va initial plus vb initial is equal to va plus vb. Now, these are vector quantities, so we need to use our component method to analyze the equation further. So, going into the x component, VA initial cosine theta, positive direction, x component of VA initial. B is initially heading in the negative x direction, so minus VB initial. In the final case, we don't know the final velocity of A, so we just use VAX. And B is heading towards positive x direction the way it came from. So, positive VB. The only unknown is VAX. So we isolate VAX. VAX is equal to VA initial cosine theta minus VB initial minus VB. We are thus able to calculate the x component of VA minus or negative 4.87867956 meters per second. Going now to the y component of the initial velocity of A, VA initial, is positive y direction. So we have positive VA initial sine theta plus 0. VB initial is horizontal, therefore no y component, is equal to VA y plus 0. The final velocity of B is also horizontal, so no y component. The only unknown is VAY. We are able to calculate the y component of VA. VAY is equal to 2.121320344 meters per second. Knowing the x component, VAX, and y component, VAY, of the final velocity of A, using Pythagorean theorem, we can calculate the final speed of ball B. VA is equal to square root of VAX squared plus VAY squared, which will give us our final answer of 5.320 meters per second. Next, we have the following problem. A 1,500 kilogram car is involved in a head-on collision with a 4,000 kilogram truck. The two stick together and are at rest after the collision. If the truck was moving at a speed of 5 meters per second, what was the speed of the car? So we have two objects, the car and the truck. Let the car be object 1, so M1 is equal to 1,500 kilograms. Our second object is the truck, so M2 is 4,000 kilograms. The truck has a speed of 5 meters per second. Let the truck be heading in the negative direction, so V2 initial is equal to negative 5 meters per second. We don't know the initial speed of the car, but for the two to hit each other, if the truck is heading in the negative direction, the car is heading in the positive direction. So the initial speed, the velocity rather, of the car is positive V1 initial. And the two are at rest and they stick together after the collision, so they have the same final velocity of 0. Using now conservation of momentum, initial momentum is equal to final momentum. P1 initial plus P2 initial is equal to P1 plus P2. The final velocities are 0, therefore the final momentum are 0. This gives us M1 V1 initial plus M2 V2 initial is equal to 0. All the variables in the equation are horizontal, so we only use x component. Using x component and substituting the values, we get 1,500 V1 initial minus 4,000 times 5 is equal to 0. There's only one unknown, so analyzing the unknown quantity V1 initial, we are able to calculate the initial speed of the car. V1 initial is equal to 13.333 meters per second. And that's it for now. In the next video, we'll go over the last part of our discussion on impulse and momentum. We'll look at explosions. So thank you for watching.